So the presentation I'm going to give, some of you may have seen most of this before. Back in 2019, I gave this presentation to the board of directors of Hayes Trinity at that time. Mr. Flatten had asked me to give that presentation, and there's a few additional slides because we have some new board members here. And so what I'm going to do is I'm going to talk about the scientific evaluation and the process that we went through to provide a document that was used as a guidance document for the board to make rules for the Jacobs Well groundwater management. So there is statutory authority. This is going to be interesting. But Chapter 36 does allow for the creation of groundwater management zone by groundwater conservation districts. So I'm not going to read all that verbatim. You can find that in Chapter 36. So with this ability to create a special groundwater management zone, the Board of Directors in 2018 created a scientific advisory committee in parallel with a stakeholder group that was created that was chaired by Robin Rather and consisted of permittees, just the general public, NGOs, the county, the cities, all the people, all the entities that had an interest in groundwater conditions in and around Jacobs Well and spring flow to Jacobs Well. And so the board charged this scientific technical committee to come up with some bounds, and most importantly, or number one on the list, is defining the spatial extent. So what is a geographic area of influence that a groundwater management zone would be created? So this is going to be really interesting. Maybe it'll keep me talking fast, or it'll do that, or it'll slow me down. I know Rusty's hoping that it'll stop speaking pretty fast, but this is going to get really. So I'll go as fast as I can. So we worked with the stakeholder group, as I mentioned. So it was an iterative process. We would present information, have discussions, take comments, and we would go back to the drawing board and kind of reassess that information and present it back to that stakeholder group, with the goal being 100% consensus on what the outcome of this technical committee would be. We looked at pumping, we looked at the water budget, we suggested some possible strategies. I'm not quite sure what's going on with this, but it'll keep me moving, I guess. And identify any data gaps moving forward. So the end result, and just kind of moving to the end, is a report. It's publicly located at the Meadow Center for Water and Environment. You can download it, and it was this technical report. And so all the figures and information I'm going to present here this evening come out of that report. The letter on the left was a letter from Robin Rather, basically explaining that the stakeholders that were part of this process agreed with what the information that was presented. So the data that we used in this evaluation, we looked at the hydrogeologic setting, the geologic structure, identified recharge area for Jacobs Well. We looked at pumping data, spring flow data, groundwater level data. So these are all the different data sets that we looked at. And so the very first cut at defining an area, which is a really hard thing to do. It's always hard to draw a line on a map from a hydrogeologic perspective where there are many uncertainties. Right? There are a lot of things that happen in the path that water takes that we don't really know. So we had to do that anyway. And so we started with the watershed of Cypress Creek, of the perennial reach of Cypress Creek. This is getting frustrating. Okay, which is this dashed line here. Here's Jacobs Well. And so we from some early evaluation that we had, looking at the water budget, looking at rates of recharge, looking at rates of discharge, and what that area that would need to provide a balance of those numbers roughly corresponded with the surface area drainage basin. So that's what we started with. And because of those uncertainties, all those things that we didn't understand completely, we added a 1 mile buffer, right? So that's our starting point. There was also this area down here, which I'll talk about repeatedly, called the Tom Creek Fault Zone, and that's the area just down here. So we came up with that starting point, with the 1 mile buffer. Not everybody liked that. Why do you have a 1 mile buffer? Why don't you have a half mile, quarter mile, 3 mile, 5 mile? Who comes up with that? We don't know. So we needed to take a little bit closer look at the details of how we are characterizing the hydrogeology of the setting around Jacobs Well. And so we broke it up into 3 different areas, right? 3 different areas of influence. One was that watershed in Cypress Creek here. One was the Tom Creek Fault Zone. And then a bigger area out to the west, including the Blanco and Pleasant Valley Spring, which I'll talk about here in a little bit later, is what we call the regional recharge area. So those were the 3 areas of influence, or potential influence, to flow at Jacobs Well. And so that allowed us to kind of break each of those down individually and do some specific analysis to understand what those impacts were to Jacobs Well. So let's start with the regional recharge area. Has anybody ever encountered anything like this?
Yeah, so what's going on is the HDMI cable that you have there is not in sync with your computer, and it loses sync and it goes back and forth. So I think it's your software, your computer, who has problems with.
Interesting. I've used that computer in lots of places, never had an issue. In fact, I think even on this one before.
Or maybe the HDMI cable is defective.
Might have a bad shortage. I'll talk as fast as I can. So yeah, the regional recharge area. And so one of the, as we're trying to understand the areas of influence, we need to understand where the groundwater is coming from and where it's flowing to. Where are those areas of regional recharge? So water flows from higher elevation to lower elevation, right? It's under the influence of gravity. And so to characterize that, we create what are called potentiometric surface maps. It's like a topographic map, but it's not of the land surface, it's of the water level surface. And in this particular instance, in the Middle Trinity Aquifer. And so here's a water level surface map, or potentiometric surface map, going from Blanco County. You can see the headwaters of the Blanco River coming through here. Wimberley's right here. Jacobs Well Springs right here. And there's some different, there are different characteristics of these maps that tell us things about the hydrogeologic system. Areas where these lines of we call them equipotential lines, or at the same elevation. Where they're close together, that means the groundwater level is very steep. Right? So it's hard for water to move through those rocks. And so it has a very steep gradient. Then we have areas where those potentiometric surfaces flatten out. That means it's really easy for water to move through those areas. And the reason that is because there's a lot of karst in this area. Right? There are caves, right? We can dive into Jacobs Well. And we know there are cave systems here. There are lots of caves in this part up around Burning Branches as well. So we know that water is coming from west to east. It hits this Tom Creek Fault Zone, and it kind of dams up again. So again, that's telling us some information about the movement of water and how that's influencing Jacobs Well. So we're going to look up gradient. We're going to look uphill to see where the water's coming from. We're not going to look downhill. First off, at least, to understand what those influences are to the spring flow of Jacobs Well. So we need to understand the geologic structure, and to do that, we take cross sections. There was a map in Hayes County. As soon as it pops up, going from the western side of by the Narrows Reef, and they drilled marjorie wells, poured those wells, going through Jacobs Well, and we come up with these cross sections. And so, two-dimensional slice, looking at the different layers of the aquifers. So we've got the Upper Glen Rose, the Hensel, the Cow Creek. The unit that we're most interested in here is the Cow Creek, which is a lower unit of the Middle Trinity Aquifer. that's the unit that Jacob's Well is flowing out of. And hopefully it'll sync up. It's just getting unsynced as possible instead of in sync. Hey, this is my son Jake here, and Otto. This is about 11 years ago. He's a big kid now. He might be playing football in 7th grade next year. Junior high football game. Did you touch anything?
No. We investigated the behind-the-scenes connection, and it is not that.
Okay.
So, I wonder, can I start this going and start again? Stop it? Start it?
Sure. So I'm going to keep on talking a little bit about this, and I'll see if I can remember as much of this as I can. So we looked at the structure and defined that regional recharge area as the water is flowing from the west to the east. The next area of influence we looked at was that Tom Creek fault zone, right? So that area just down gradient or down the water slope from where Jacob's Well is. It's where all those equipotential lines got very close together. So we wanted to understand how the aquifer is connected on either side of that fault zone and within that fault zone to the area around Jacob's Well. And so we look at water levels in wells. So we have sensors that go down into wells and can give us a kind of a time graph of what that water level is. And if you look at wells that are in either the vicinity of Jacob's Well in that surface water basin of Cypress Creek, and the ones that are in that Tom Creek fault zone, hopefully you can picture that in your mind still, but it's that area just a little bit to the southeast of Jacob's Well. Those wells behave differently than ones that are found further down gradient, or what we call down dip, further to the southeast, like when you get into the town of Wimberley and to the east and south from there. And so what that told us was that the aquifer had a much less degree of connection to the flow of Jacob's Well as the area that's in that surface water basin up from the spring and that further west recharge area along the Blanco River. I don't know if it's worth taking a 2-minute break to try to get this up or not, Charlie.
I think we're close.
There it is.
All right, we're close.
Yes, replace the HDMI cable. Thank you guys so much. So you should be rock solid.
Rock solid. That's what we can hope. All right, Lee. Perfect. Well, I'm glad they brought it up because in that regional recharge area on the Blanco River, there's a very important feature that we've identified in the last 10 years. It turns out it's the largest spring in the Middle Trinity Aquifer, Pleasant Valley Spring. So we discovered this in 2013, and if somebody goes back there and happens to hover over this picture, it's actually a little video. But on the Blanco River, coming up from the bottom of the riverbed is a spring that has water that's boiling up. So this is coming out of a karst conduit. It's not as well developed as Jacob's Well. It's not as big around. It hadn't had as many years to develop over time, but it's got a lot more water flowing out of it. It's coming out at a higher pressure. And so in 2013, when we were in drought conditions, we were taking measurements, and that meant we would go out, and you can't measure the flow as it's coming up out, so we would measure the flow downstream and upstream, subtract the difference, and we could quantify how much water was coming out of the spring, and it corresponded with the flow of the Blanco River at Wimberley, there at Ranch Road 12. Well, and there's no other springs between that were flowing at the time, so all the water at the Blanco River in town was coming from this one location. This is Jacob's Well at that time, so you can see it was very low 1 cubic foot per second down to 0. Another interesting thing about Pleasant Valley is it's coming out of fractures that are the same rotation as the fractures that Jacobs Well is flowing from. So here's that the Tom Creek fault zone. Again, just down dip, so down that structural dip. So those faults are moving the geological layers down as you go towards the east. And so we knew that wells in this area corresponded, the water level corresponded with patterns that we saw in this area. But wells that were down here did not. This is just another closer look at those fault blocks. So again, wells that are kind of right in here behave similarly to wells that are completed up around Jacobs Well, but wells that are down in this domain are different. And so here are those time series data. So you can see wells, water levels in wells in the up dip or the northwest are relatively flat. And when we have that flat water table up in that area, they do respond rapidly to precipitation or recharge events. That's what these spikes are. But then it flattens back out again. That's due to the fact that there's a big spring that water's flowing out of. You can see that those correspond with periods that the flow at Jacobs Well, shown here in blue, is increasing. And for reference, here's the Blanco River at one point as well. But if we look down dip, down this area, we see not only are those water levels much lower in elevation, but they also have a different pattern. They respond, they have a higher amplitude of response, and they're much more subdued. They do respond to recharge, but in a different way than the wells that are in a direct connection with Jacobs Well. This is just another view of a few more wells, again showing that difference between the up dip wells in the fault zone and in the basin, and what we call the down dip wells that are outside of the fault zone. In case you need a refresher, this is what we're looking at here. This water table here, and how it changes over time, and how the differences in this area are versus the differences in this area. And so in the Jacobs Well Spring catchment area, the area that's eventually became the groundwater management zone, there's some really interesting patterns that we see in the connection between the spring and the wells in this zone. I mentioned that our starting point with this whole process was the surface water basin with that 1 mile buffer. We've done some analysis where we were trying to understand that water budget. We can estimate how much water comes in through recharge. We can pretty accurately quantify how much water comes out through the spring flow record that the USGS reports and through pumping data. And over a long time period, those numbers should roughly equal out, just like for your bank account does, or hopefully it gets bigger. But and so we used a few different methods that were published in the literature, and these are very simple models. So it's not a really detailed numerical groundwater model like ModFlow, like Jeff Watson presented last month. These are really simpler kind of water budget models. But we can use that information to estimate the area, the surface area, how many square miles of precipitation, where some percentage of that precipitation makes it down into recharge, how big of an area do you need? So the bigger the spring, the bigger the area, right? So Comal, San Marcos Springs have a huge recharge area that goes way out west. Uvalde, smaller springs, more localized springs are going to have much smaller catchment areas or recharge areas. And so those, using all these different methods, the spring shed of dry Cypress Creek really corresponded pretty tightly. So we think that's a pretty good correlation. There's a lot of other evidence about what's going on here in the fabric of the rock. We have caves, underwater caves, that the spring's coming out of, that we know that it's developed in Cow Creek. Here's a picture down at about 140 feet in the top of the Cow Creek limestone, and the caves formed along these fractures, really classic karst evolution here. And so we can correspond those cave maps with the levels of the geology that we have correlated with the geophysical logs and wells, and we can see the caves all in the Cow Creeks. Cow Creek is the layer that all the water is coming out of, and really the most productive unit in this part of western Hicks County. So here's where it gets a little interesting. If you look down to the lower left here, this is a little inset of that map here. You can see Jacobs Well Spring. There's a few permitted wells, Wood Creek 23, Wood Creek 21, in particular interest. And so when we put the stream, the gauge in to measure the flow at Jacobs Well back in 2005, particularly when we get down into lower flow conditions, we notice these weird patterns. Every day there seem to be about 3 peaks and 3 troughs in the water level. Well, we got data from a pumping well, and it turned out that those peaks and troughs corresponded with when the well was on, and the water level dropped at the well, and the well was off. Well, spring flow would drop at the well.
I'm shocked.
The flow would drop, and then the pump would turn on, and it would come back up. Well, there's another well that has an influence as well, and so there's supposed to be another, oh, here it is, well 23 right here. Here's a period where this well 23 was turned on for 24 hours, and so it had a downward shift. And so that downward shift is kind of superimposed in that spring flow record of Jacobs Well. So these wells have a pretty tight connection to the water that's flowing out of the spring. It's pretty easy to tell. So here's a map of permitted wells in all 3 zones. You can see most of them are in the, either in the fault zone or the catchment area. There are a few out in the regional recharge area, but most of the wells out there are all exempt wells. So here's a look of all the pumping that occurs in these 3 areas. So we can kind of break it down by area to see what the influence is. Well, out west in the regional recharge area, from 2008 to 2018, this 10-year period, there's not a lot of pumping. There's still not a lot of permanent pumping that occurs out in that neck of the woods. You can see the 3 different, the 2 different zones, the fault zone and the Jacobs Well catchment area here in green, a little bit more, and then this is the sum of all 3 of those zones here. So, higher pumping rates are usually in the summer, lower pumping rates are in the winter. So, after going through this process, after getting feedback from the stakeholders, having discussions, we came up with these 2 zones. The Jacobs Well Groundwater Management Zone and what we call the Regional Recharge Groundwater Management Zone. And those are the suggested areas that we presented to the Hayes Trinity Groundwater Conservation District Board in the fall of 2019. And I think the rules were passed in January of 2020, if I'm not mistaken.
I think it was March.
March of 2020, yes. Okay. Just before the whole world shut down. So some other ways of looking at this comparison between pumping and flow at Jacobs Well Spring. If we look in a drought period in 2011, you guys can remember back how hot and dry that was. This is a monthly summation of flow. So if you just took all the flow out of Jacobs Well in a month and quantified that value and compared it to pumping. So you can see going from January to August. In January, most of the water coming out of the aquifer. So we've normalized pumping into cubic feet per second, just so we can compare apples to apples here. As you can see that there's a lot more water coming out of the aquifer in that Jacobs Well, what's now the groundwater management zone in the catchment area, than there is pumping. But when we get into these summer months, the spring flow basically dried up and it would go to 0 for a few days. So a very small amount of volume came out in the month of August, and a large amount came out as pumping. So that's what we're trying to balance here. How do you balance these two things to coexist in the same area? We can look at, again, these periods over a longer period of time. These are drought periods shaded in gray. Again, we can see pumping generally goes up and spring flow goes down. So it has this inverse relation. Here, if we look and zoom in, back in 2011, here's where it was a zero flow, looks like in September. Again, spring flow has gone down, pumping's gone up. Just another way of looking at the same set of data. So this is what we're trying, or what was tried, what we're trying to address. How do we deal with these peaks in summer pumping that are replacing spring flow that normally come out of Jacob's Well? Can you put restrictions, drought restrictions similar to those that are used in the Edwards Aquifer or other places that are based on spring flow, and apply those same techniques to the Jacob's Well catchment area, or what's now known as the Jacob's Well groundwater management zone? And so in 2019, the stakeholder group and the technical group, we recommended these types of reductions. And I think the rules actually don't have a 2 CFS 40% reduction, but I think that the difference was that these suggestions were based on permitted amounts, and Mr. Flight, I think the actual rules have something to do with some type of actual usage amount, if I'm not mistaken. But I'm not clear on the rules. We didn't advise that specifically, but this is what's in our document in 2019. So I think now we've been in 30% reduction for quite a while.
Triggers.
And triggers, yeah, thank you very much. These triggers are at different flow rates at Jacob's Well flow. So this is just a comparison of what the possible flow triggers could have, how they could have impacted flow at Jacob's Well Spring. And the percentage of time that you would be in any one of those different triggers. So 30%, this is based on historical data that we looked at, you know, so about 20% of the time you'd be in 30% curtailment. So just a way of looking at it, how frequently you would be in one of these drought stages. Another thing that we looked at just as kind of a point of reference, or how impactful had drought restrictions been in the past, prior to the creation of the groundwater management zone. And so this is what pumping is. This is average pumping over a period of time that's shown on a monthly scale. So it's many number of years, 10 years taken the average of the pumping and what that actually is on a month-by-month basis. And the green line is what was pumped, or was a period with no drought declared. And the red line here, this is actual data, is when the district was in some form of drought restrictions, and there wasn't much of a difference. This dashed line is what those differences should have been. So if there was going to be a 20 or 30% reduction in those periods, there should have been that much of a decrease in pumping, when in actuality there was only this much of a decrease in pumping. So it was really just a way of looking at the effectiveness of the existing drought curtailment system and what effects it was having. So finally in our report, we just outlined and identified some tools that can be used to help conserve water and or use water differently to try to ensure spring flow at Jacob's Well. There's drought curtailments, education, right? Teach people how to use water more wisely, conservation, permit restrictions and reductions, increase the infrastructure, the efficiency of the infrastructure to fix the leaks, conjunctive water use, using surface water and groundwater where it's applicable, and these looking maybe into the future at aquifer storage and recovery. These are all just suggestions of ways that could potentially help supply water to the people in western Hays County, even in times of drought, and try to maintain some spring flow. Looking at water resources in the Lower Trinity, rainwater harvesting, other water supplies. Again, just kind of give them a bucket list of things to look at. So I'm going to close out here and talk about Rule 16, which was passed at the same time that Rule 15, which created the groundwater management zone for Jacobs Well. Rule 16 created this regional recharge groundwater management zone. And there was a 5-year study period that initiated at that time to try to understand how important is this area with similar types of rules permanently need to be put into place. And to really evaluate that, we need to see what's going on in that part of the aquifer, how the groundwater and the surface water interact with each other, particularly the health of the Blanco River. And so a lot of the work that we've done over the years has been to identify the interaction between the surface water and the groundwater. So here we see a cross-section going from really back west into Blanco County, coming into Hayes County, where you can see there's springs that come out. That water goes back into the ground, comes out as maybe smaller springs. In Blanco, all that water then goes back, in this area goes back into the aquifer and comes out in a series of springs that I'll talk about here in a second, from Park Springs to Pleasant Valley Spring. It's the spring that I showed the video of. And then flows on down past Wimberley and eventually into the Edwards Aquifer. It's recharge, and then goes to San Marcos Spring. So a really dynamic system in the Blanco River. Mr. Flatt mentioned I teach at UT, so have students out doing flow measurements and trying to understand these patterns. And one area of interest is a few miles west of Wimberley. So here's Wimberley here, and this reach of the Blanco River, which we'll call the river reach of, or the spring reach of the Blanco River. And the reason we call that is because the river is bone dry here, and in this particular instance, it's flowing 35 cubic feet per second. That's a lot of water. Particularly comparing to Jacobs Well. I don't know how often Jacobs Well flows 35 CFS, but I've only seen it a few times. And so there are a series of springs through here, ending with Pleasant Valley Spring, the furthest downstream spring. And I mentioned those fractures that it's flowing out of are the same orientation as the fractures at Jacobs Well. The springs at the exact same elevation as Jacobs Well, so it has a lot of similarities, and it's coming out of the same part of the aquifer. But it's really important. Sorry, there was a couple of slides that I skipped over there. All right, so again, 35 CFS, so the flow is increasing. So if you're familiar with this area, Burnett Ranch Estates is right around here. Valley View Road, there's a low water crossing that goes across the Blanco here. Down here is Fisher Store Road Bridge. And so there are a couple of springs that are up in the Burnett Ranch Park, Little Park Spring and Park Spring. They're still flowing a little bit today, but not a whole lot. There's a spring here that's really what we call an estival. An estival is a karst feature that is a recharge feature under low flow periods and is a spring under high flow periods. It's kind of like your overflow in your bathtub. When the tub gets up high, it'll flow out over. So when the aquifer levels get high, the water can flow out. And this is one of the points that it does that. And in fact, Miller Spring can flow as much as 50 to 60 cubic feet per second, probably a lot more than that. That's just as high as we've quantified it. But the base flow is all coming out of Pleasant Valley Spring. It's the lowest, furthest downstream spring that's providing the base flow. And so what we've done, the Edwards Aquifer Authority is funding USGS. We installed gauges at Fisher Store Bridge in 2015, right after the flood, and right after they rebuilt the bridge. And then a couple of years later, we put a gauge at Valley View Road. So what this allows us to do is we can quantify the spring flow out of all these springs, and we know that under low flow, it's all coming out of this spring. But we can quantify that flow by using those gauges. So really important. Here's a hydrograph of Valley View Road. You can see This is the last year. Hasn't had a drop flow past in the last year. You can see this is the flow coming out of Pleasant Valley Springs. And it would be all of these springs in total, but the water that flows out of Park Springs over the last year all goes back underground before it makes it to here. So this stretch through here has been dry the last year. And so how does that relate to what we see here at Wimberley at Ranch Road 12? There's a USGS gauge. It's been there since the 1920s. It provides historical record. I think it's a drought trigger for the whole district, if I'm not mistaken. And so here are hydrographs in green is the gauge here in Wimberley. And I just took this a little while earlier today. So these are values from yesterday. It was flowing 7.8 cubic feet per second at Ranch Road 12. The darker color here is the USGS gauge at Fisher Store Bridge. It was flowing 9.6. So that loss is probably due from evaporation in that reach of the river. But generally, over the last year, these numbers are pretty much the same. So what does that tell us? It tells us that all the flow of the Blanco River that comes through Wimberley, at least when Jacobs Well is not flowing too much, is coming from Pleasant Valley Springs. So it's really important to protect that spring moving forward. And Rusty will be happy to know this is my last slide. That's a side joke of the presentation I gave a few weeks ago. But again, just in reference to the importance of this regional recharge area to the flow of the Blanco River. And you know what's interesting is, again, there's not much pumping in this area, so there's not as much existing impact from pumping that's taking place in this area as we have in the other two areas. And with that, I'm happy to take questions from board members or anybody else. That was Jake's, when Jake was a year old, that was his only word, and he got to name the dog. Thank you all very much. Jessica.
She has a question. I'll go next.
Thank you.
I'm very curious about this Pleasant Valley Spring, that so much of the quantity of the Blanco River comes from that spring. And I heard you present at the water workshop a week ago, and you mentioned that that was discovered, so to speak, in 2013, and it's all on private ranch land. Well, what happens if a developer comes in and buys that private ranch land and starts pumping, builds who knows how many houses? What's that going to do? I mean,
I couldn't tell you specifically, but there's the amount of water that's in the aquifer is how much is there, right? And it changes over time with how much rain we have. And so whether that comes out of spring flow or is extracted through pumping is up to how the properties in the surrounding areas are used.
well, my follow-up question about that scenario is there anything that we can do as citizens to be sure that recharge of the Pleasant Valley Springs is secured in the future for the Blanco River?
Sure.
I mean, what can we do?
So there are many tools that are in the toolbox, and I'm not necessarily the best person to talk about those, but there are programs like conservation easements that many nonprofits, different entities, agencies, there's a bill that's before, that has passed the House, I think now, and is waiting for Senate passage that would create a couple $2 billion to create a fund for conservation properties. And so that's one of the best tools that's used for that. And then beyond that, it's the toolbox that the groundwater districts have to manage that water resource. So those are probably the two best, I would say.
In the interest of time, I'm going to ask the board members, do you have any questions for the presenter at this time?
Yes, very quick question. So with all the knowledge you have now,
Yes.
you know, we have the drought stages, 30%, 40% in support. It seems to me that by the time you set 40%, it's already too dry up. So
Yes.
based on the study that we're presenting here today, do you propose a better way to establish percent drought stages in these particular areas before the flow rate that K goes to zero?
Potentially, and that, to answer that question, it's kind of a moving target, because it's always hard to predict the future.
Yeah, but you can look at monitoring well before.
You can, right. So, you know, I would say if you had restrictions that kicked in earlier, that were, say, larger, so let's just say, I think it's 6 CFS, it went to 10% or something, let's just say it's 6 CFS, you went to 20 or 30, you could potentially conserve more water. In the context of this work, and the work that our technical committee did, it was in conjunction with stakeholders. And so we had to all agree on what was the scenario that could work, not only for the management of water and spring flow, but also for the people. There are other people using the water. And so we did our best to balance that. And you know, it's the world that we live in, and we all have to figure out how to use the resource together the best we can.